So section 5.9 is on complex numbers. So it says try to solve the equation x squared plus 1 equals 0. You subtract 1 from both sides, you get x squared equals -1. So then we know we take the square root, and whenever we take the square root, we write plus or minus, right? When we're the one taking the square root. If the square root wasn't already there, if the square root was already there, it's just plus. But if we take the square root, we write plus or minus. So I get x equals plus or minus the square root of -1. So what do we write? What do you guys always put when you do the square root of a negative? Right, you guys always wrote no solution. So this time, we're going to introduce a new set of numbers. So remember when we first learned about numbers, we talked about the Venn diagram, and we said, okay, well we have real numbers, and that's all the numbers that we know now. And then real numbers break into rational and irrational. Do you guys remember that? Okay, so now we have a whole new set of numbers. So if it's not real, it's going to be something called complex, or we sometimes call them imaginary numbers, right? Real and imaginary. Okay, so we have a whole new set of numbers. Okay, these numbers are when you take the square root of a negative. So it says in order to solve equations such as these, we need to be able to take the square root of negative numbers. Therefore, we define the square root of -1 to equal I. So when you see that, you're like, what? What's I? So there's a lot of numbers in math that are defined by letters. So, you know, pi. Pi is a letter. It's a Greek letter. All right, and we've defined it to be 3.14159 and so on. All right, I is now defined to be the square root of -1. Later on, we're going to talk about e, which is another number that's on your calculator, and that's like 2.718. Okay, so there's lots of numbers in math that are defined to be certain things. So I is the square root of -1. Okay, so number one, if I have the square root of -1 as I, what are the following? So what's I squared? So I squared would be the square root of -1 squared. So what do you think it is? -1. So I squared is -1. All right, let's simplify all of these other ones so that it's either I or 1, -1, or -I. So simplify powers so that you have I, -I, 1, or -1. Okay, so we're going to get it all the way down to that. So even if I have like I to the 508, I'm going to figure out how to simplify it down, okay, to one of those things. All right, so B, I have I cubed. So I cubed is I squared times I. What did we say I squared was? -1. So I have -1 times I. So that's why that's -I. So do you see how we're going to be able to simplify these things down? So we're always going to think about how many I squareds go into it. Okay, this next one's I to the 4th. So I to the 4th is I squared times I squared. And I squared was -1. Yep, so I have -1 times -1, so I get 1. Okay, how about I to the 43? So you can think about how many times I squared goes into it, which was -1, right? I squared was -1. But I think the best thing to do on these big numbers is to think about how many times I to the 4th goes into it. So how many times would I have I to the 4th? 10, right? That would be 40 right there. How many would be left over? 3. So times I cubed. And what's the convenience of using I to the 4th? So what is I to the 4th? 1. So do you guys see how this is just 1 to the 10? So that's just 1. It's just all 1. So times I cubed. And then we did I cubed before. Remember, I cubed was -I. So that's from that one. Okay, does that make sense? Okay, you guys try I to the 29. Why did I cancel the I to the 10, or the 1 to the 10? Because 1 raised to the 10th power is what? 1. So if you're multiplying by 1, it's all just 1, right? Okay, I cubed. So let's go back to the I cubed. I cubed was, break it down, it's I times I squared. And I squared was negative 1, so it's I times negative 1, which is negative I. It's just what we did up here. You what? Yeah, just, I mean, if you're multiplying, if I multiplied by 1, right? Isn't it just the same thing? So we ignore that part because I'm multiplying by 1. It's the same number. That's all I did. All right, so the next one. So I to the 29th. So think about how many times 4 goes into 29. How many times? 7. So that means you'd have I to the 4th 7 times. So it would be written out 7 different times. Okay, so how many is that? So that's 28 I's, right? So how many do I have left? 1. Okay, what was the convenience of using I to the 4th? It's 1. So this part is all gone. So this is 1. And then I to the 1 is just I, right? So I to the 29th simplifies down to just I. So that's what I was telling you, that everything simplifies down to I, negative I, 1, or negative 1. So I to any power is going to simplify down. Santiago, are you confused? Okay, so let's try the next one. So if I have I to the 32. So let's do each one separate. So if I have I to the 32, how many times does 4 go into 32? 8 times. How many are left over? None, right? All right, Santiago, pay attention. Okay, so 4 goes into 32 8 times. So I have I to the 4th, and then it's all raised to the 8th. Okay, but the convenience of using I to the 4th was I to the 4th was 1. So I have 1 to the 8th, which is just 1. So that first part's 1. Okay, now let's talk about the second part. What's I to the 7th? Okay, we're going to take care of that in a second. So if I have I to the 7th, think about how many times 4 goes into 7? Once. So it's I to the 4th to the first power, and then how many are left? 3. So I to the 4th is 1, so all that part's gone. So you can just cross it out. That's all 1. It's negative I, right? Okay, so now let's go back to the original. So you had 5I to the 32 minus 6I to the 7th. So we just said 5 times I to the 32 we just found was 1, minus 6I to the 7th was negative I. So you end up with 5 plus 6I. And that's it. So I to any power can simplify down to I, negative I, 1, or negative 1. If you want to write yourself a little note up here. So I is just I, obviously. I squared, what was that? Negative 1, because it was square root of negative 1 squared. I cubed was negative I, and I to the 4th was 1. So you might want to use that on your homework as you're simplifying down. Because you'll always get to one of those 4 things after you do the I to the 4th to something. Okay, so number 2. So express each number in terms of I. So you guys remember how when I had square roots, like if I was trying to simplify square root of 8, I broke it down to square root of 4 times square root of 2 because we knew what square root of 4 was. We knew it was 2, so it was 2 root 2. So we're going to do the same kind of thing here. So if I have the square root of negative 121, square root of negative 121 is the square root of negative 1 times the square root of 121. What was the square root of negative 1? So this part's I. And then the square root of 121 was 11. So I get 5I times 11. So it's just 55I. Okay, the next one. So I have negative square root of negative 96. So I have negative. This is going to be the square root of negative 1 times the square root of 96. So I know I have a negative out front and an I out front because the square root of negative 1 is I. But we still need to simplify the square root of 96. Oh, I'm going to pause real quick because I think Miss Webster's coming. All right, so simplifying square root of 96. So just like before. So how do I simplify square root of 96? 6 times what?
16.
Yeah, 6 times 16. That's not one that you guys may know. Like if you guys needed to do the factor tree off to the side, you could do that. Remember how we did that one time? So some people know that it's 12 and 8, so maybe that would work. And then 12 and 8 breaks into 4 and 3, and then 4 and 2. So you get 2, 2, 3, 2, 2, 2. And remember when you're taking the square root, you're looking for pairs. So you have a pair of 2's, a pair of 2's, and then you have a 3 and a 2 left on the inside. So you end up with 4 root 6. Okay, but what Kern was saying is he knew that 16 went into it, which is good, because if you have the square root of 16, we know that's just 4. And he said 16 times 6 is what made 96. So you get negative I times 4 times the square root of 6. So that's what gives you so 4 times negative I. So negative 4I is out front and then square root of 6. So it's like that. A lot of people kind of ask, usually if we're just doing problems like part A, we had the I on the right side. So a lot of people say, can you write it as negative 4 square root of 6I? And you can, but remember we talked about if your square root lines get a little long, sometimes it's hard to tell where the I is, if it's under the square root or not. So usually we put it in front of the square root. Okay, so the first one, so 3a, if I take the square root of both sides, I'm going to write plus or minus. So whenever you take the square root, write plus or minus. So I get x equals plus or minus. What's the square root of negative 144? 12 what? I. So basically the negative under the square root becomes I on the outside, because square root of negative 1 is I. And then the square root of 144 was 12. So square root of negative 144 is 12I. Okay, you guys try part B. Let's go ahead and try part B. Okay, so subtract the 90 over. And divide by 5. So you get negative 18. So I think all of you guys got there. Okay, so then when you take the square root of both sides, you have to write plus or minus when you take the square root. So you get x equals plus or minus the square root of negative 18. So that's the square root of negative 1 times the square root of 18. All right, that's why we have an I out front. And then square root of 18, that breaks down into the square root of 9 times the square root of 2, which gives you 3 root 2. So your final answer would be written as plus or minus 3I root 2. Okay, so how many of you guys got it? Not very many. Okay, we're going to have to do some more. All right, so a complex number is a number that can be written in the form a plus bi, where a and b are real numbers and I is the square root of negative 1. So I is always the square root of negative 1. So every complex number has a real part. So when you look at a plus bi, what's the real number in it? A. It's the part that doesn't have an I, right? And an imaginary part. So that's just b. That's the part that has the I. We just write b, we don't write bi. So this table is really easy. So your real part for the first one is 3, your imaginary part is 4. Okay, how about for the number 9? What's its real part, what's its imaginary part? What? 9 and 0, good. So Kendall said 9 and 0 because this is 9 plus 0i. There were no i's there. Okay, the next one's pretty easy. It's -4 and -7. Last one's a little harder. So Santiago, how about this one? So if I have 8i, what's the real part? What's the imaginary part?
8 is real. 0 is imaginary.
Okay, other way, because the imaginary part has the I, so it's going to be 8 is imaginary and 0 is the real. So 0 and 8. Makes sense? Okay, the reason we do this is because later on, like in other math classes, you might graph imaginary numbers, which is very strange, but there's a, you don't have to write this, there's a real axis and an imaginary axis. So we graph it like an ordered pair. So we'd go 3, 4 for the point 3 plus 4i. So that represents that number in an imaginary plane, which is crazy. All right. So real numbers are complex numbers with imaginary part equal to 0. So that was like this one. This is a real number. Pure imaginary numbers are, so that's like this one, are very similar. They have real part equal to 0. So we call it pure imaginary because it's pure. There's no real part with it. It's only imaginary. Make sense? Okay, that's why the complex numbers are sometimes called imaginary numbers. Okay, so a complex conjugate. The complex conjugate of any complex number, a plus b, there should be an I there. I don't know what happened to it. So a plus bi is a minus bi. Okay, do you guys remember when we talked about conjugates of square root expressions, like 2 plus square root of 3? Do you guys remember what the conjugate of that was? So if that was on the denominator, what did you multiply by? 2 minus the square root of 3, right? So you just change the sign in front of the square root part. Same thing here. You just change the sign in front of the I part. So same thing. So like I said in the past, I've had questions on the test, like give the conjugate. So it might be like a square root or an I or something. And I always think these are like easy points. Like, oh, everybody's going to get these. These are 2 points each. You know, you know it or you don't. And then people miss them all the time. So these are easy points. So on number 1a, so I have 8 plus 5i. So what's its conjugate? 8 minus 5i, right? So that's what you would multiply by if it was on the denominator. So just like square roots, if we have i's in the denominator, that's bad. All right, how about 6i? Right, because 6i is 0 plus 6i. So its conjugate is 0 minus 6i. You don't have to, but if you need to see it. So, or negative 6i. Okay, how about c? It's a tricky one. Negative 2i minus 15. So if you need to rewrite this first, this is negative 15 plus 2i. So its conjugate is negative 15 minus 2i. Or the way you guys said it was negative 2i minus 15. So you're just changing the sign in front of the I part. That's it. So if you need to rewrite this one, this is square root of 3 plus I. So its conjugate is square root of 3 minus I. Or you could have negative I plus square root of 3. Okay, makes sense? Easy test questions. All right, so just like with square roots, we multiply, divide, add, subtract. Okay, so it says adding, subtracting, and multiplying complex numbers is very similar to combining variable expressions. So if I had x's, it's just like x's, except if you have I squared, we know I squared is negative 1. So sometimes you're going to use that I squared equals negative 1. Division is the most difficult. you're going to get your final answer in the form a plus bi. In order to do this, you might need to multiply the numerator and denominator by the complex conjugate of the denominator. Okay, so the first 5 are easy. So let's do the first 5. So I'm just going to combine my i's just like they were x's. So in the first one, I'm going to get 8 minus 2i. Make sense? So I just rearranged. I did the 3 plus 5, and then I did the 4i minus 6i. So 8 minus 2i. Okay, the next one, let's go ahead and distribute the negative, just so we don't make any little errors with the negative. So I'm going to have 4 minus 2i minus 3 plus 2i. Negative 2i and plus 2i go away. So you just get 1. Okay, the next one, we actually need to FOIL. So first is 3 times negative 2, so negative 6. Outer is 3 times 4i, so plus 12i. Inner is negative 7i times negative 2, so plus 14i. And last is negative 28i squared. Don't forget the I squared. That's the biggest error people have on these. Okay, remember I told you you're going to use the I squared equals negative 1. So we know I squared is equal to negative 1. So that means I'm going to replace. So I really have negative 6 plus 12i plus 14i. Then I have negative 28 times negative 1. So plus 28. And then I combine my like terms. So negative 6 plus 28 becomes 22. And then I have 12i plus 14i. So that's plus 26i. And that's your final answer. Okay, you guys try 4 and 5. So try 4 and 5. All right, so on number 4, it's just an addition problem. So you're just going to combine your like terms. So if you want to drop the parentheses first, you can, but it doesn't really matter. So when I combine my like terms, I have negative 2 minus 6, so you get negative 8. And then you have 6i plus 7.8i, so that's 13.8i. So you should get negative 8 plus 13.8. I forgot my 0.8, didn't I? So 13.8i. Did you guys get that? Okay. So the next one you're going to need to FOIL. So your first is negative 6. Outer is negative 2i. Inner is negative 24i. And last is negative 8i squared. Okay, like I said, the biggest error is people will just write negative 8i instead of negative 8i squared. I see that a lot on the test. Okay, whenever you have I squared, we don't want to leave it as I squared. I squared is negative 1. So you're going to have negative 6 minus 2i minus 24i minus 8 times negative 1. So what's negative 8 times negative 1? So we write plus 8, right? So I end up with negative 6 plus 8. So I get 2. And then the inner is negative 26i. Okay. So I think the adding, subtracting, and multiplying is pretty basic. The only thing you need to remember is that I squared equals negative 1 when you're multiplying. Okay, the division is a little bit harder, but it's just like when we had square roots. So if I have 4 over 6 minus I can't leave it like that. I need to write it in the form a plus bi, so everything needs to be on the top. No i's in the denominator. Okay, so what do I multiply my denominator by? Yeah, so the complex conjugate. So instead of having 6 plus I, I'm going to multiply it by 6 minus I. And the reason we do that is because, or sorry, instead of 6 minus I, I multiply it by 6 plus I, right? I said it backwards. All right, so that's going to give me like the difference of two squares, so the outer and inner terms are going to cancel. So let's multiply by 6 plus I on the top and the bottom. So when I do that at the top, you just distribute the 4 in. So 4 times 6 is 24. 4 times I is 4I. And on the bottom, we have to FOIL. But like I said, the convenience of this is we use the difference of two squares, so the outer and inner terms cancel. That's the only way you can get rid of the i's. So your first terms make 36. Your outer is plus 6i. Your inner is minus 6i. And your last is minus I squared. So you get 24 plus 4i on the top. 6i and negative 6i cancel. So what does the bottom become? Right, it's 36 minus I squared, and what was I squared? Negative 1, so let's think through it. So if this is negative 1, so I have 36 minus a negative 1, 36 plus 1, so 37, right? And then your final step is to actually bring that 37 into both pieces. So we actually write it as 24 over 37 plus 4 over 37i. And the whole reason we do that is because that graphing thing I talked to you about. So we do that later on in math. We graph complex numbers. So this way we kind of have it set up so you can see that ordered pair. Okay, so that's it. Okay, so let's try some more. So on number 7, I'm going to multiply by 3 minus 4i on the top and the bottom. Okay, number 8, you can multiply by negative 3i, but all you're trying to do is get rid of the I. So what could I actually multiply number 8 by? Yeah, do you guys see how you just need I? So on number 8, you're going to multiply by I over I, because then the bottom becomes 3i squared, which is negative 3. So it becomes a rational number anyway, like a nice real number. Okay, and then number 9, before I even start, what does that mean if I have something to the negative 1? Yeah, it's 1 over all of that, right? So it's 1 over 5 plus 2i. Basically, all of that's to the first power. Okay, so you would need to change that one. You would need to multiply by 5 minus 2i over 5 minus 2i. So how about you guys try those 3 problems? I'll walk around and help. Okay, so number 7. So we're multiplying by 3 minus 4i on the top and the bottom. So that means you have to FOIL the top and the bottom. So your numerator becomes 15 minus 20i minus 6i, and your last is plus 8i squared. Okay, that's all over. So when you FOIL the bottom, you get 9 minus 12i plus 12i minus 16i squared. Okay, I squared we know is negative 1. So whenever I see I squared, I'm going to replace it with negative 1. So as I'm combining, so can you guys kind of do this in your head on the top and the bottom? If you're combining, you'd have 15 minus 8. Do you guys see why I have 15 minus 8? So 15 minus 8. So that's going to be 7. And then I have negative 21 minus 6i, so negative 26i. On the bottom, my 12i and negative 12i cancel. And I have 9 plus 16. This ends up being plus 16. So 9 plus 16 is 25. So you end up with 7 over 25 minus 26 over 25i. Okay, so did you guys find your mistakes? Figure it out. We separate it because of the graphing thing. Like later on, when we graph this, this is the point 7 over 25, comma, negative 26 over 25, when we use the real plane and the imaginary plane. But we don't do that later. Well, I mean, we do that in like pre-calc. So it gets really nice to like graph. There's crazy shapes, like you'll see like petals. Yeah, and that involves imaginary numbers. Yeah. But imaginary numbers are really useful in like electrical engineering and things like that. Yeah, you're like, what? Okay, so number 8. So a lot of you were asking me why you multiply by I on the top and the bottom. So if you multiply on the bottom, you have 3i squared. Okay, which is negative 3. So that made that a real number. So all we were concerned about was getting rid of the I. Now you could multiply by negative 3i, and that would be fine. Just in the end, you'd have a fraction that reduces. You know, like fractions like 18 over 6, you know, you'd get 3. So you'd have to reduce fractions, which is an extra step. So, okay. So on the top, I have 6 minus I times I, so it's going to be 6i minus I squared. So it's 6i minus a negative 1. So I have 6i plus 1 over negative 3. And I always say write in a plus bi form. So that's not like a plus bi over c, like over another number. It's a plus bi form. So I need a number plus another number times I. So when I bring the negative 3 into both pieces, I get negative 2i plus a negative 1/3. So that's almost in the form a plus bi. But what's wrong with it?
Wait, how did you just wouldn't you have to multiply it?
I brought this into both pieces. So it's like I wrote it as 6 over negative 3i plus 1 over negative 3. It's the opposite of getting common denominators. I just pulled them apart.
Okay.
Okay, so it's almost an a plus bi form, but what's wrong with it? You can't have, what? You can have a fraction. B could be a fraction, or a. It's backwards, right?
Oh, yeah.
You have bi plus a. All right, so you just rearrange. So it's going to be negative 1/3 minus 2i is your final answer. And the reason we want it in that certain order is because that graphing thing. Like you have an x coordinate and a y coordinate if we were going to graph it. Okay, so is it break time? All right, go and break, and then we'll do the last one. Last one. All right, so I have 5 plus 2i to the negative 1. So that means it's 1 over 5 plus 2i. So negative 1 means 1 over. So I'm going to multiply by 5 minus 2i and 5 minus 2i. So on the top I get 5 minus 2i, and on the bottom I get 25. My outer and inner are going to cancel. That's the way I've designed it, so that they're going to cancel. So then I have minus 4i squared. So that's really going to be plus 4 on the bottom, because I squared is negative 1. So it's negative 4 times negative 1. So I get 5 minus 2i over 25 plus 4, which is 29. So you should get 5 over 29 minus 2 over 29i. And that's it. You guys like eyes? I know it doesn't make much sense now why we have eyes. You're like, why am I doing this? But they really are useful in a lot of like graphing and things later. They're Gabby's new favorite thing.
It's so fun.
You should write a love poem to I.
I wish you did. I did not. You'll know.